Okay, so so yesterday, this is where we ended up. We took a look at this particular function. We're able to come up with the vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. We're going to do all that same stuff here with this next one, except the directions are slightly different where I want you to sketch it. So we're going to pull out all that information, put all of it onto a graph, and see if we can piece together what we have. Okay? So take a minute. See if you can get those four things we were talking about yesterday again. Vertical and horizontal asymptotes, and then the x and y intercepts. Okay, I will freeze this, and I will do the same, and we can compare what we got there, and then we'll move on after that.
Really bloody. Yep.
Now, one nice thing about this one, you don't have to factor it, right? So it should speed that process up a little bit. All right, if you're not done, don't look at the board. But for those of you that are, you can check how you did. Okay, does anybody need more time with this, or are we okay with that first part? Ask. Oh, go ahead.
Can you find the horizontal asymptote?
The horizontal asymptote is found by looking at the degree of the top versus the degree of the bottom of this fraction. If the degrees are the same, which they are in this case, then you divide the leading coefficients. So 1 divided by 1, y equals 1. Any other questions about any of the four of those before we move on? So we're all okay with that? Yeah, question. The y-intercept, you get a y-intercept by plugging 0 into the function. So 0 and 0, so negative 2 divided by 1 then would be negative 2. Okay, so let's start plotting this stuff out. Okay, so I drew a little coordinate plane down here underneath, and we're just going to start placing this stuff on there. So I'm going to make a little scale here, make sure it's all nice and even and pretty. Okay, so we've got a vertical asymptote at x equals negative 1, so that'll be here. And horizontal asymptote at y equals 1, so that'll be there. Alright, so you got both of those on there. And then x-intercept is at 2. That's right here. So there's an x-intercept. And we have a y-intercept at negative 2. That would be down here. All right. So with all of this information on here, and I'll go ahead and finish up the scale I have on this thing. We want to see if we can kind of visualize what's going on as far as how this thing fits together. It needs to fit within the asymptotes, and it needs to make sure it goes through those intercepts as well. So let's talk just down here in the bottom right, because there's lots of stuff going on there. Can you guys kind of visualize in your head how this curve has to go? It has to fit within the asymptotes, and it has to cross those 2 points. Can you guys all see that? So it's going to be this curve that kind of comes up like this. Okay? So let's go ahead and fill out that part of it, because that, it seems, is fairly clear with how that should look. Okay, does that kind of a thing. So now the question is, though, is that it? Is there anything more to it? Well, we know there has to be, because in this particular case, the domain, the numbers that work in this function, should be everything except for -1, right? -1 is the only part of the domain that's missing. So that implies that anything to the left of -1, there should still be something there, right? There should be a piece of that graph hanging out over there somewhere. Okay? The only thing is that part of the graph will never cross any of the axes, because all the intercepts that we have are on there. It's just those two. Just this x-intercept, just that y-intercept. So over here, we can't cross anything anymore. So remembering that these little pieces have to be caught in the asymptotes, could I have a piece that goes like this? Why not? It would have to cross the x-axis to do that, right? So we can't have one underneath this horizontal asymptote over here, because it would produce an x-intercept we know can't be there. So where's that other little piece going to have to go then? It's going to have to be up in here, right? And it's going to approach this asymptote and approach that asymptote. So it's going to be this little curve that's kind of caught like that in there. So we can finish off what this graph looks like then by doing that. All right, so this particular function that you guys started with here, x minus 2 over x plus 1, that graph should look like what you see underneath there then. Okay, so let's verify. Take out your calculator, type it up, see if we get the same thing. We should. It should be looking similar to this. And I would make, when you do this, your window, kind of like what I did here. If we just go out to 4 each direction, you should get a better look at it. Otherwise, it might be kind of small. And again, when you're typing this thing up, just be sure that you're using your parentheses, so it should look like that when you type it in. And then the window, like I said, we'll start with -4 to 4, just so it's the kind of the same scale I just made, and see if it looks the same or not. Sometimes these pieces that don't have any intercepts or whatever, they might be kind of a little further away than we anticipate, but see what it looks like here. All right, so not too bad, right? Looks pretty much the same. Now, your calculator doesn't plot the horizontal asymptotes. And in some cases, your calculators won't plot the vertical ones either, right? So mine does have the vertical one in there, and the horizontal one would be kind of right there. So you can kind of visualize what that would look like. But it's a good verification that, yeah, we got pretty much what we were supposed to get when we graphed that thing. Okay, looked like that. Okay, let's do one more of these. And the next one, this one was just to kind of get the ball rolling a little bit. This next one is a little bit more challenging. It's got a little bit more going on. Okay, so this is going to be kind of the entire process. All of those little things that might pop up that are going to cause you problems, we're going to look at those in this, okay? So in this case, we're going to sketch x to the third minus 4x over x squared plus 2x minus 3. And as soon as I start to go for vertical asymptotes on this one, I realize, oh crap, I got to factor this thing first, right? So the numerator and the denominator of this are factorable. Okay? So let's see if we can come up here. Let's take care of that and rewrite it in factored form. So the numerator, how can I factor that numerator if it's x to the third? What do you notice? Yeah. Pull out an x, okay? And when I pull out that x, I have x squared minus 4. We'll come back to that. Denominator can be factored. Anybody figure out what those two are? Yeah, Josh? X plus 3 and x minus 1. Okay. Now, that numerator can be factored further, right? So if I have x squared minus 4, what does that factor to? Right. So here's what we're really working with. I'll make it nice and big so we can see it. X times x minus 2 times x plus 2 divided by x plus 3 times x minus 1. Okay, so, like I said, a lot more going on this one than the last one. So, let's see if we can look at that and get all that information that we need, though. Vertical asymptotes, where are they at for this one? -3 and 1. So x equals -3 and x equals 1 are our two vertical. All right, the horizontal asymptotes. That one we want to go back to our original, right? Take a look at the degree. The degree of the numerator is larger than the degree of the denominator. So what does that tell us? There's not going to be any, right? There are none. All right, x-intercepts. Take a look at that factored form of this thing. Where are the x-intercepts? 2 and -2 for sure. And at 0. So we have 3 x-intercepts happening on this one. Okay, and then the y-intercepts. Remember, to find a y-intercept, we simply plug 0 into the original function and see what we get. So what should that produce then? 0, yeah. Now think about that for a second too. That should make a bit of sense based on the x-intercepts we just came up with. If I have an x-intercept of x equals 0, shouldn't I have a y-intercept of y equals 0 too? Because an x-intercept of x equals 0 is where? Right at the origin, right? So you should have a y-intercept at that same place. Okay, so that just kind of verified that for us there. Yep. Okay, so let's get all of this stuff onto a graph. Try and make mine as pretty as I can for you here. All right, let's see.